Algebra 1, Post Chapter 10, Worksheet 1. Let me explain. These are worksheets that we've done throughout the years that are required because they're not covered in our textbook, but they are covered in the Algebra 1 Michigan Merit Curriculum. So the way I've designed this, obviously everything's been different since we've been going online. The way I'm going to do these next 4 lessons are I'm going to partially fill out the worksheet with you, and you should download it ahead of time and do it with me. And then the parts that we don't do, the ones that we leave blank, that will end up being your homework. At the moment, I'm not exactly sure which ones I'm going to do, but just complete the worksheet, and that'll satisfy. Obviously I'm not grading you for this anyway, but that'll satisfy me that you picked up the concept, and you'll be good to go when we talk more in depth about this in your Algebra 2 class next year. I am on my website right now. These are just what I named them in my folder throughout the years. D1 is day 1, D2 is day 2. Okay, so we're going to be doing day 1 right now, and after I finish this video, I'll put the link in the right up here, and I'll have the 4 links to the 4 videos. But what you should do before you continue with this video is click on this and print it, or if you can't print it, then maybe somehow use an iPad or whatever, so that you can kind of practice this along with me, and then eventually you should figure out a way to print it so that you can practice those problems that we don't get to. I will share keys, but probably not for several weeks. Okay, because I can see that a lot of people haven't even started on Chapter 8 yet. So I'll wait a few weeks, and then I'll get keys up as well. But if you're here, if you've made it through Chapter 8, that's the only reason you should be watching this video. Then download this, print it out, and then continue with this video. I did want to mention this real quick too. So this is the link to my 10-8, and then this is the book homework. The next 4 assignments are not going to have book homework. It's only going to be the worksheet. Okay, so jumping over to my starboard, it's something called vertex form of a quadratic. This was not covered in Chapter 10. It certainly will be covered in depth in your Algebra 2 class. This is kind of an introduction to that, so it's not totally foreign to you when we get to it in Algebra 2. And it's just another form. You know how lines have slope-intercept form and point-slope form and standard form? Well, there are really 3 common ways to write a quadratic as well. 3 for a line, 3 for a quadratic. One of them is standard form. That was what was focused on in Chapter 10 of Algebra 1. And another one would be factored form, which we did cover as well. And then there's this thing called vertex form, and it's convenient because you can see the vertex. Okay, so it's a different form, and h comma k, right here it says that h comma k is the vertex. Now notice that this is naturally a negative where this is naturally a positive. Okay, so if this was x minus 5 and this was plus 2, the vertex is 5, 2. If this was x plus 5, we would assume minus a negative. The h value would actually be negative 5. You have to assume that. You have to infer that, I guess is what I want to say. So it's vertex form. And again, if they give us something in this form, we can immediately plot a point because we know where the vertex is. That's why this is valuable. Okay, so again, moving to the worksheet now, I have it just pasted in here on my starboard. We'll see how we do with this. Sometimes it helps to just look at one that's pretty typical. I'm sorry that it's blurry too. I just clipped it over, and this is as clear as it came through. So let's look at number 13 first. And this is in that exact form. Y equals 2 times x minus 3 squared plus 1 is in vertex form. And what I'm telling you is that right away what you can do is figure out that the vertex is 3, 1. And you can put that right down there. Okay? And if I just look over a little bit further, if I look at number 16, this is x plus 3. Again, you want to assume that then is minus negative 3, and then there's a positive 1. This vertex would be at negative 3, 1. Now, one thing you can do, and I think it will be on a later worksheet, just to kind of prove this to yourself, that's a comma, by the way, right? So it's, yeah. Just to prove this to yourself is that you could, manipulate these things back and forth. One thing you can do is turn something that's in vertex form into standard form. And what you'll notice is that the lead number the number that first shows up to the right of the equal sign, is the a value. There's a reason why we said that vertex form is y equals a times parentheses x minus h squared plus k, and it's because the a value is the same a value that was in standard form, ax squared plus bx plus c. They use the same letter because it actually is the same number if you manipulate them. You can also manipulate them the other way, go from standard to vertex form. That is also coming on a later worksheet. Okay. Now, with that in mind, let's jump to the top, and we'll just do a few of these. All of these are in vertex form. They don't look like it. Y equals x squared doesn't look like y equals a parenthesis x minus h squared plus k. But really what it is it's just y equals 1 parenthesis x minus 0 squared plus 0. Okay? We don't bother with plus 0. We don't bother with minus 0. And we don't bother with multiplying by 1. So it's just y equals x squared. But before I scribble those out, if you just looked at those, that would give away the vertex. Now, you probably already knew that this had a vertex of 0, 0. That's what it's going to be. Okay? Now, for the rest of this, as much as you need to, so I can plot the point 0, 0 like that, as much as you need to, use a t-chart. Okay? Now, you may not need to use it on the first few, but as soon as you need a t-chart, those are always available to you. Use a different piece of paper or put it in the margins here somewhere and do that. So what if I plug in a 1? 1 squared would be 1. There's 1, 1. What if I plugged in a negative 1? Careful with this. I see a lot of mistakes here. Negative 1, all of it squared would be 1. Negative 1 in parentheses squared would be 1. 2 squared would be 4. So 2, 4 would be like this. And negative 2 would also give you 4. And 3 would give you 9. That's a little bit farther than we gave you here. So you go ahead and you draw the parabola. So at the start, this isn't going to feel any different than what you did in chapter 10 until we get into the parentheses like these problems here, right? Otherwise, it's going to feel a lot like standard form. But what I want you to start doing right away is looking to see what the vertex is, okay? Now, for 2, 3, 4, those are all going to have a vertex of 0, 0, okay? So you could fill that in right now if you want to, because there is no plus this or minus this. There are no parentheses to show you what the h value is. There's nothing tacked onto the end to show you what the k value is. We assume that there's 0 then. Okay, they are, not just that we assume it, they are 0. They are assumed to be 0. Okay, so then let's look at 4. Again, the vertex is 0, 0. Okay, and if I plug in a 1, I'm not going to really like the output so much, right? Because 1 squared is 1 times negative 1/4 would be negative 1/4. I'd have to plot the point 1, negative 1/4. So think about it just for a second while I plot 0, 0. Think about what would be a convenient number to plug in there. Not 1, but would 2 be okay? Wouldn't 2 be better? Because 2 squared is 4 times negative 1/4 would be negative 1. There's, 2 negative 1 would be like this. And I'm doing the best I can on this starboard. A lot of times when I paste something in, it doesn't cooperate as well, but I'm doing what I can. Negative 2 squared is 4 times negative 1/4 is negative 1. So here. And then I wouldn't plug in 3 because 3 squared is 9, and then you're trying to plot negative 9/4 when it would be much more convenient if you would go up to the next even number, which would be 4. 4 squared is 16 times negative 1/4 would be negative 4. We have 4, negative 4. Also negative 4, negative 4. And that's enough to go ahead and plot a parabola. Remember, like I said in chapter 10, that these are not dot to dots. They are a curve, and you should do your best to show a curve. If I can do this on this computer screen that's kind of malfunctioning right now, you ought to be able to do the same with pencil and paper. Okay? All right, let's jump down. Well, let's do number 5. And now, again, there's no parentheses, right? So it seems that there's no h value, and in fact, in reality, it's just 0. But the k value would actually be negative 3. You see vertex form, which, by the way, I wrote it down on the notes. It's also on page 2. You can see it in the directions, vertex form of a quadratic. The natural form of the k value is positive. So when we see a negative, that means that the k value is negative. It's like saying plus negative 3. So this would be 0, negative 3. And plot it right away. 0 and negative 3. Okay? And again, use a t-chart if you need to. I don't think that's probably necessary yet. You can plug in 1, 2, 3. You can plug in -1, -2, -3, and you'll get points that look like this. 3 squared would be 9, 6, right? So and there. Now, one thing that I have on my key that I haven't mentioned so far is I do have a scale. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and you probably should do that. You must do that if you change a scale. You know, when I give graph paper and it's blank, and somebody doesn't put a scale, and they do it right, you know, they do it right if the scale were by ones. I usually ignore that. Obviously, if you're going to change a scale and go by something other than ones, like twos or halves or tens or whatever, you must put the scale on there then. And by the way, the scales don't have to be the same from one axis to another. You can go by ones on the x-axis and thousands on the y-axis. Doesn't matter. Those do not have to be consistent. All right, jumping over to do another one that's a little different. How about number 7? Now you have parentheses. The a value is assumed to be 1. I think that was true of number 1, number 2, and number 5 that we just did. 6, the a value would be -1. But I said let's do number 7. So the a value here would be assumed to be 1, right? There's a number in front here that we just don't write. And then the h value would be 3. The k value would be 0. This is like saying x minus 3 squared plus 0, right? And for that reason, then, the vertex is 3, 0. I can plot that point 3, 0. I'll plug in some other numbers that are near it. You might remember this from chapter 10. I'll go ahead and make a t-chart this time that I did this. 3, 0. And then maybe you try 2 and 1, 4 and 5. You pick numbers that are close to the vertex. We had a different way of finding the vertex back when it was standard form. We had a calculation for that. Now it's evident in the equation itself. So I plug in a 2. 2 minus 3 is -1. Squared would be 1. I plug in a 4. 4 minus 3 is 1. Squared would be 1. That's not a coincidence either. We expect that to happen. I plug in 1. 1 minus 2 is -2. Squared would be 4. If you plug in 5, you're going to get 4. And there's more points that I can plot. 2, 1, 4, 1, 3, 4, I think is right. Yeah. Okay. Now I'll leave a lot of this left for you all to do, but let's go ahead and finish up the 2 at the bottom that we started with. If the vertex is at 3, 1, then we can plot the point 1, 2, 3, 1. The a value here is 2. That's going to make the parabola narrower, just like the a value did in standard form. So anyway, let's make a t-chart again. Put 3, 1 right in the middle here, and then maybe pick 2 and 1, 4 and 5, and see how we do with that. 2, now be more careful with this. Use a calculator if you must. 2 minus 3 is -1. Squared would be +1. Times 2 is 2, plus 1 is 3. Let's confirm that by doing it with 4. 4 minus 3 is 1. Squared is 1. Times 2 is 2. Plus 1 would be 3. Do the same thing with 1 and 5. 1 minus 3 is -2. Squared would be +4. Times 2 is 8. Plus 1 is 9. And 5 minus 3, 2. 2 squared is 4. Times 2. You follow the orders of operation. We're doing in parentheses. Then the exponent. Then it gets multiplied. Then it gets added. 9. Okay, so points that I can plot, the 9 is just a little bit off, but you could still probably squeeze it in there. 2, 3 is like this, 4, 3, and then 5, 9, 3, 4, 5, 6, 7, 8 is just one tick off, if you will. And then you can draw a parabola, like so. Okay. Actually, I'll leave the rest of them for you all to do. This video is getting kind of long, and we got to get to the back page still. 17 through 20 go right along with what we were doing already, so we'll leave you with that. There's where it says what vertex form is, just like I had in my notes. The vertex is h comma k. And then they're just going to ask us for the vertex, whether it opens up or down, and whether it's wider or narrower than x squared. I think we'll just fill out this whole thing. The vertex, if you want to go slower than me, you can always pause me here. The vertex would come from this number and the fact that there's a plus 0 assumed, and that would be 5, 0. The vertex is 5, 0. Does it open up or down? Who remembers how we determine whether something opens up or down? In chapter 10, we said in standard form it was about the a value. If the a value was positive, it opens up. If the a value is negative, it opens down. And here the 2 is actually the same a value as would be in standard form. So this one would open up. And as far as wider or narrower, you can just use a W or an N and determine whether it's wider or narrow. That also is based on the a value. And the a value being 2 is greater than 1. The a value of this would be 1. It's greater than that. So it's 2. That means it's going to be narrower. It's kind of like the last problem that we did. It's narrower because it's just causing it to grow faster, if you will, as x goes up. So N for narrower. Okay. What I'm saying is this graph is, might look like this. And the graph of something that has a 2 for an a value is closer to the y-axis at any given height. Okay, so continuing quickly, the vertex here would be -1, -6. Confirm that. Make sure you agree. That's a negative, so this would open down. And 0.4 is less than 1. This would actually be wider. This would cause it to grow slower, or in fact, it's negative, so it would open down, but it's going to cause it to be wider, so W. Here you're going to have 0.5. Just make sure you agree. It's going to open up and it's wider. And then here you're going to have -4, 2. It's going to open down and it's narrower. And then the last one is basically giving you the vertex and you write the equation, okay? So they're saying to start with the parent function, in this case, y equals x squared. And if the new vertex is 2, 0, it'd be like shifting from 0, 0 to 2, 0. And we're going to put it in vertex form. So this would be y equals, the a value is 1, so the a value would remain 1. We don't have to put that. Parentheses, the h value is 2, so that's going to get subtracted from x. Don't forget your squared. That's a really common, easy mistake to make, is to forget to put squared there. It's not a quadratic if you don't put squared. And then plus 0, which we won't bother to write. Next one, y equals, I'm going to use their -2, right? The a value should remain the same. And this is really a shift down of 5, if you can understand that. So that's vertical. The h value is 0, so no parentheses. We can just put x squared. Now, if you put in parentheses x minus 0 squared, that would be technically right. I wouldn't count you down for something like that, but we don't need it. Okay, and let's just do one more, and then I'll leave the last 3 for you to do. Y equals, I'm going to use their 1/3, and then x minus -1, right? Minus negative, you should change that to plus, squared, and then plus 4. And I think I'll stop there. Please finish the worksheet before you move on to worksheet 2. Thanks for tuning in.